All right, so another proof here. So we're given that AD is parallel to BC, right? We're given that AD is congruent to BC, and we want to prove that AB is congruent to CD. So a lot of times when you're trying to prove that two segments are congruent or two angles are congruent, you want to think about CP/CTC, right? And if you want to prove that CP/CTC is true, or corresponding parts of congruent triangles is true, you have to prove that two triangles are congruent, right? So that means we're going to use ASA, AAS, SAS, or SSS, right? It doesn't necessarily have to be in that order, but those are the triangle congruence theorems, or postulates and theorem, right? This is the one that's a theorem, the other three are postulates. All right, so we want to use one of these, and then we're going to use CP/CTC. Okay, so let's start with our givens. So I'm given that AD is parallel to BC. Segment AD is parallel to segment BC, and that's a given. Okay, also given AD, all right, let me just write this on the same line. I might need that space. So segment AD is congruent to segment BC. Okay, so I'm going to write that information in the diagram here. So I know that AD is parallel to BC, and I also know they're congruent, right? So I'm also going to put tick mark here. Okay. All right, so when we're given that two things are parallel, a lot of times we're going to use alternate interior, alternate exterior, corresponding angles, or same side interior, right? So when you see parallel, that should lead you to think about, a little thought bubble here. You should be thinking about alternate interior, exterior, corresponding, right? Or maybe same side interior. Okay, so those are things we're thinking about when we see parallel. So if we look at this situation here, we already have two sides congruent, right? So really, any of these is on the table, right? Because they all need at least one side. So when we have parallel lines, we can see that, okay, well, these parallel lines and this transversal form angle 1 and angle 2, which are alternate interior angles, right? So we can say that angle 1 is congruent to angle 2, right, by alternate interior, alternate interior angle theorem, okay, which says if two alternate interior angles are formed by two parallel lines in a transversal, they must be congruent. Okay, so we can say angle 1 is congruent to angle 2. I'm going to say BCA is congruent with angle DCA, or DAC, excuse me. All right, and I'm going to say alternate interior angles theorem. And remember, I want you to start getting away from using theorem 3-2 or whatever that is, because I want you to first of all know what the theorems are called, or kind of what the meaning behind them is, and also to get used to using that as opposed to some arbitrary numbering system, right? That works in our book, but it might not be the same in the next textbook that you use, or the next professor or teacher that you have might have a different system. Okay, all right. So we know that these two angles are congruent, right? So now we basically kind of eliminated side, right? So we can do angle, side, angle, right? We can do that angle congruent with this angle. We can see if that works. We can do side, angle, side, right? We can see if this side is congruent. We could do angle, angle, side, right? We can do angle, angle, side. Okay, so we have some different options. But the one I mentioned second, this one right here, knowing that AC is congruent to AC, that one's pretty obvious, right? By the reflexive property, we can say that side AC is congruent to itself, right? So by the reflexive property of congruence. Okay, so now we have enough to say side angle side. Okay, so two side, or excuse me, not side angle side. Yeah, side angle side, I'm sorry. Got a little twisted there for a second. So we can, so we have two sides and the included angle, right? Two sides and the included angle. So triangle DAC is congruent with triangle. Remember to get your order right. So B corresponds with D, so B is going to come first. C corresponds with A in this case, so C is going to come next. And then A corresponds with C, so A will come last. And that's because of SAS postulate, right? And last but not least, we can say that side AB is congruent with side CD because of CPCTC. So, since these triangles are congruent, that means that AB must equal DC.